All right, talking about file I/O. We've seen a little bit about it already in the assignments. And last time I had an example of a file name. I'm reading it in, or I'm opening the file, pardon me, in read format. This happens to be the name of the file. I hit run, and we're good. Read, text, there we go. This only worked because I actually had uploaded the file to Colab. If we were running Python on our computers, it would work if the file's in the same working directory, but let's not worry about that too much right now. So that's great for reading. And like anything, you know, if we have, let's go down here, AF for a file dot, and like there's a whole bunch of things we have here. Flush, file no read, readable read line, seek, you know, there's a whole bunch of methods we have there that we can play around with. And the best way to learn this is to just try them out, see what you can do. Maybe you find something handy, maybe you think, oh, well, I'm only ever going to need read, whatever. So that's reading from a file. I wonder if we can write to a file. As you could probably guess, of course we can. Except here, I'm going to open up a file called anotherfilename.txt, except instead of the R, we've got the W. And who remembers from last time what we think the W means? Right, of course. W for write. Makes sense. So I'm lazy, I'm just going to copy this. I'm going to put this here. Run it. Great. So my other file dot, and look, there's a whole bunch of other things. And no, did you notice something there? That file just appeared. Right? Who here noticed it just kind of like pop up? Nobody. Well, it did. A moment ago it wasn't there, but because I actually created the file called anotherfilename.txt, and I said, okay, Python, open this up. Python, because that file didn't exist, it had to create it. Let me show you again. Watch carefully. I don't know how Colab times it, but let's... There. Another. And last time I did it when I did this. Watch carefully over here on the left-hand side. We'll see if it pops up. It might need me to like do something, my other file name dot. Ah, there we go. Did you see it? I saw some of you looking down. You missed it. Well, that's okay. Now the other one, another file name dot txt. There we go. Great. So you know what, let's take a moment, see if you can figure out how to write stuff to this file. Go ahead, do it. And then once you think you've written to the file, write to it a bunch, however much you want, write to it, and then open the file. See if you can see what you wrote. I'll give you a minute or two to play around with this because I think we can manage this one. If you just, by the way, if you ever double click one of these files here, it kind of like Colab opens it up. So that's an easy way to check what you've done. Raise your hand if you wrote stuff to your file. One person. All right, I'll give you like a minute more, see if you can get it. You might find a giant hint on the board. I don't know. For me, the most obvious method here seems to be right. And I don't know. Is this working? Okay. Oh, 16. Well, that's interesting. Let's see, another file name. Oh. But there's nothing there. Did anyone run into this? Where they wrote to the file, but nothing was there? No, no one had that issue. Well, that's interesting. So that means, like, when you're shaking your head no, does that mean you wrote to the file and it was there?
No, I didn't get that. My files won't upload to cloud.
Oh, you don't, for writing to a file, you don't need to upload anything. So it's weird, right? Because I opened up another file name in write. Other file name write, is this working? Let's see, maybe I come down here. And I'll say my other file dot. Probably going to want to go to a new line. Whoa, don't know what just happened there. Strange. New line. Why is there no output? Okay. I don't know, like it looks like another file name. There's nothing there. Does anyone have any idea what's going on? Maybe, I don't know, maybe I can download. Let's see, maybe, no, there's nothing there. That's weird, right? Anyone have any idea? It'd be kind of weird if you had an idea. I had to close the file first. You don't always technically need to close the file. But listen carefully. Whenever you open up a file like this, you always need to close the file. Because otherwise, you might run into the problem we just had. I'm going to tell it to you now. This is another one of those things of, remember this. You'll forget to close a file every once in a while. You run it. Why is it not outputting what I'm expecting it to? Think, oh, did I close? That's the takeaway from here. So here's actually how Python and many programming languages deal with writing to files. Any file I/O is really slow. Okay? So here's what the computer wants to do. The computer will put all the stuff that you want to put into that file into like a temporary buffer, which is just a fancy word for saying the file's there. I'm going to put all the stuff I want to write into that file here, not over there, here, temporarily here. And then every once in a while, I'm going to put this into the file. The motivation behind this is, imagine I write some arbitrary number of lines to a file. Let's say n lines. That means I'm going to be writing to that file n times. And each time I write to that file, it's slow. So here's what the engineers thought of. Well, what if we just kind of put those n things we want to put into the file here, which is really quick to do. I could just store it in like a list, let's say. That's easy. And then I will take all those n things and do one write. Because file I/O is so slow, that's like the hack that they did in order to speed it up. Just because the computer overhead with going to that file, opening it up, it takes so long. So then it flushes the stuff from the buffer into the file. When I closed it, whenever you close a file, it guarantees that we flush the buffer. If we don't, we might run into a situation where I look at the file and the stuff in the buffer never actually wrote to it. Long story short, close your files once you're done with them, especially when writing to them. See this function, flush? You might guess that forces the buffer to flush. Yeah, that's what it'll do. Many programming languages work this way, so they have similar methods and functions. Anyways, close them. Yeah, there we go. All right. If you're ever working with data, one of the most common file formats you're ever going to see is CSV. Stands for comma-separated values. You can think of it like a table. Like, look at that example there I've got. Name, height, weight, IQ. Maybe I'm doing some sort of analysis where I want to see, I don't know, is weight and height related to IQ in some weird way? Probably not, but who knows? I only have a couple of records there, but do you see how it's like a table, kind of? It's got rows and columns. You may remember from assignment 1, if you open up that location CSV file, Excel or some spreadsheet application would open it up for you. It's because Excel's being like, oh yeah, this is tabular. Check it out. Look, isn't it nicely formatted? Great. But really, it's just a whole bunch of data separated by columns, or by commas, and there we go. Each row corresponds to a row. Each thing, the commas separate columns. Great. CSV is very popular, very handy. Use them if you're ever storing and loading in data. You like CSV. You might also remember from assignment 1, we opened up the file and loaded some contents from the file to do assignment 1, the Starbucks stuff. But I didn't, see how I've got open starbucks.csv and read? You see that? But you also notice I've got it wrapped in csv.reader. And I've imported CSV. Python makes it super easy to read stuff from comma-separated value files. If you import CSV and you say, okay, Python, this file is a CSV, open it as a CSV, it's going to load it up really nice and great and already kind of formatted for you. It's fantastic. So that's why I can say, immediately, R, the row from reader, which is the CSV file, I can already index it as if it's a list. Because it'll treat each row as a list, and then columns are the elements in each list. So it just makes it a little easier. You don't have to worry about memorizing this. This is just me telling you oh, hey, by the way, if you ever need to load up a CSV, Python makes it that much easier for you. Not many programming languages make file I/O this easy. And this is why a lot of people who do data analysis love Python, because it's so easy to open up the file and do all your analysis and whatnot. For fun, let's do this activity. Download this CSV file here. If you're using Colab, you're going to have to download it and then upload it to Colab. And what do I say? Write a function called load airports that loads the CSV file into a list, and then play with around a little bit and see how the data is organized. I'll give you a couple minutes to just play around with this. I won't give you too much, because if you don't get it figured out, this is something you can do on your own if you ever need to deal with file I/O, but I want to give you a chance. So take a couple minutes, download that file, upload it to Colab, and try to load the data in. And I'll give you a big hint. You might look at this for inspiration. You might have to make some changes, but this will probably be pretty damn helpful. Oh, I completely forgot. I was going to make an announcement at the beginning of the class. This is going to be a huge distraction. We were talking about it a little bit yesterday in lab, so if you're in lab yesterday, this is a little bit of a recap from lab yesterday. But the final exam, I found out from the registrar, who had originally planned on scheduling the due dates of all the final exams, that they decided not to do that. And an email went around a little while ago that I missed. So anyways, I set the due date. So here's what I'm going to do. At 1 p.m. on the 2nd, I think. 2nd's the last day of class, right? Yeah. So at 1 p.m., that is the moment I'm allowed to release take-home exams. I will make it available to you at that time, pending technical difficulties. I will then, the recommendation is they say, have your final exams if they're take home, give them 5 up to like 7 days to do it. So I'm going to make it due the next Wednesday, because I think the 2nd is a Wednesday, I think. Can someone verify that? So I'm not, it is, yeah. I'm going to make it due that Wednesday at 11:55 p.m. So it's slightly more than 7 days technically, but I don't think anyone's going to complain too much. So that's what I'm going to do for it. I'll also send an email out to everybody, but FYI, that's how the final exam is going to, that's when it'll open and that's when it'll close. So you'll have about a week to do it, plus a little bit of time, so there you go. The flexibility on time is because I know many people have other exams, so this just gives you time to kind of plan and work around that. Now that you've been sufficiently distracted, try this a little bit more. Oh, look at that. Colab even beautifully formats the CSV for us too. Look at that. Wonderful. Okay. All right, so I took the code and changed it slightly. I renamed the function, replaced, oh wait, I guess all these comments are wrong too. There we go. Replaced it with the proper name, changed the list name, and instead of like appending R at 0, R at 1, I just append the whole row, because the row is a list, great. And do that for each row. And then down here I loaded the data that I printed it out. And you'll see that we have a list of lists, or more accurately, we have a pointer to a list of pointers to lists. So right here, I mean the first one seems to be airport code airport, okay. Then we have ABE, and that corresponds, to Allentown, Bethlehem, Easton International. If we go all the way to the end, yay, I added Halifax there, great, look at that, YHZ, Halifax, fantastic. So that's cool. So instead of doing this, write a function get name from code airport list that will return a string containing the full name of the airports with the code airport code. Okay, so you'll notice that if we go here, you know, it's got like YHZ, Halifax, Stanfield, YYZ, oh my goodness, I'm all over the place. YYZ is Toronto and so on. So the goal is write a function that will take an airport code and then give me the actual name of the airport. So if I say YYZ, it will say Pearson, Lester B. Pearson International. Make sense? So if we think about this, first I'm going to do it, good old linear search. Sounds like it will probably do the trick. So def get name from code, a list. I'm lazy, a airport code, a list, airport list. Okay. So I've got a list of lists. Okay, so each row corresponds to an airport. Code name. I'm lazy, I call it AP. In a list. So for each airport in the list, I'm going to say if AP at 0, because the 0th index was the code, is equal to a code, that means I found it, right? If I'm going through that list of lists, or pointers of lists, a pointer to a list of pointers to lists, and I find the code I'm looking for, the airport code, then I just return AP at 1. At this stage, this should be kind of obvious to you. It's just a linear search. AP at 1. Otherwise, do nothing and carry on to the end. Great. So let's see. Print, get code, and I'll give it like YYZ. That's near the end of the list, and I'm going to give it AP for airport list. Look at that. It worked. Now, this is the same old story I've been talking about for a while. I've got some arbitrarily large number of airports and airport codes. Let's say I have n of them. If I'm doing a linear search, I mean, we saw YYZ was near the end. I may have looked for YHZ, which is Halifax, which was the end. It just so happened to be the last one in it. It's like the nth one, or n minus 1 if we're counting from 0. Worst case scenario, how many things am I going to have to look at? How many airports will I have to look at before I find it in the worst case? Someone has to have an idea. All of them, all in. It's a linear search. Now, do we remember from I think it was literally last week, do we know of a data structure we could use in this scenario that might make this a little bit better? Who said it? Do you? It was you? You were going to say it, right?
Dictionaries.
A dictionary will make the key the code, because the codes have to be unique, and then the value associated with that key will be the string. So I'm going to make this change right now, and you'll see how easy it is to make this change. And then you'll see how much simpler the search, the get name from code will become. All because of the power of dictionaries. I'm going to go here. So I'm going to read it in, but I've got this airports. That's a list. I don't want it to be a list. I want it to be a dictionary. And for each row, I'm going to say airports at R at 0, because R at 0 is the code, is equal to airports, I guess R at 1, because that's the string. Technically, that first row, which is kind of like the headers of the columns, that's like airport code, airport name. I guess I can do like one read line to get rid of that. How do I do this again? I'm trying to remember. I'm not sure if that works with the CSV file, but let's have a quick look. Oh, reader, read line. Shoot. Well, whatever. We'll just be lazy and ignore the fact that the first thing in that list is the airport code, airport. Great. So now I have a dictionary, and I've associated the keys, which are the airport codes, to the strings of the airports. Now let's look at how simple, by using this dictionary, let's look at how simple I can make this. No need for a linear search anymore. Simply return a list. Actually, I probably shouldn't call this a list anymore. At a code. Done. Look at that. Look how much simpler that is. And if we remember from dictionaries, if I have n things, n airports, how many do I have to look at before I find what I'm looking for? Worst case scenario. What? 10? And? No. That's if we're doing a linear search. Now I'm using a dictionary. How many things do I have to look at? 1. Dictionary just tells me, here's the key. There's the value associated with it. Now, technically, there's some fancy, weird, funny stuff going on in the background, but we'll worry about that next year. Long story short, though, dictionaries are awesome. Okay, great. You can write to CSVs, there you go, whatever. Now I'm going to talk about exceptions. You have undoubtedly encountered exceptions before. Who here has seen something like, a value error, invalid literal for int with base 10? This is saying I can't convert the string hello into an integer, because that doesn't make any sense. So Python's telling you, I can't do this. Or list index out of range. Who here's had this bug before? Everyone put up your hand, I know you have. So here's the thing. Exceptions are not necessarily errors. A lot of times they are great for indicating that there's a bug in your code and you can fix it, but exceptions are not necessarily errors. An exception is a very super special thing programming languages have. And they're used to make you aware as a programmer or the user of software, that's like code. Like if you download a library and start using someone else's code, exceptions are a way to communicate to you that something exceptional happened. Not necessarily an error, but something peculiar. And the problem with exceptions, just as thinking of them as errors, is sometimes you can lose sight of the utility of what exceptions can be good for. Sometimes you get an exception. And what you want to do in that scenario really depends on your current situation. Let me show you what I mean. Yeah. Great. Here's an example of me writing code. Look, this is a ridiculously stupid question or a function. It's a function that says, do not give me 5. You give the function n, and you print out n. But, if for some reason the person using this code passes the number 5, I'm going to return, or I'm going to raise, not return, but raise is kind of like a return, but for an exception, I'm going to raise value error. And I added the string, I told you not to give me 5. And there's me using it. I gave it 5, it says value error, I told you not to give me 5. So let's say for whatever reason you needed this super important function, I don't know. And someone gave you 5. Someone put in 5. What are you going to do about it? What do you want the code to do if you see that exception? Here's another really good example. A much better real-world example. You write a function called divide. I know that you already have the division operator, but let's say you had to write this function. Because someone had to write the function for divide. Someone had to write the code to tell the computer how to divide. If b is a 0, what is something divided by 0? You don't remember? Is it 1? Oh no, come on. What happens if you divide something by 0? I heard a lot of different answers. It breaks. You can't do that. What else was said? Undefined. Undefined. This is a problem. If the code does this, it's not necessarily an error, but this is an exceptional situation. Somebody tried to divide something by 0. What do you want your code to do if this function gives you that exception? What do we want to do? When an exception is raised, that tells us something exceptional happened. We can catch exceptions. Something funny happened, it raises the exception. And then you, who's deciding, what do I want to do in this situation when that exception gets raised? You catch it, and then write the code for what you want to do. Now, I'd like to explain the idea, and I'm going to give you a couple examples. Okay, here's the thought experiment I guess I propose, or pose before giving you an example. Pretend I wrote the divide function in 1999. Okay? You come along today in 2020, that's 21 years ago, or 21 years from 1999, and you're using my function. I wrote it in 1999. And you're using it, because it's really important. this isn't that crazy because you've all used a divide operator in Python and someone wrote the code for divide. And that code for divide is going to throw that exception error, or that exception for divide by 0 issues. So pretend this is the case. It's 1999, you come along and you want to use it. And you type in divide 9 by 0 for whatever reason. Maybe you didn't even type this. Maybe your function takes some values from a parameter that some user inputs, and then you pass it to the function. Okay, so you didn't even write the code that says 9 divided by 0. You wrote the code that reads inputs, but the user misused your code and tried to pass in 0 to divide. So this is that exceptional situation. What are we going to do about this? So let's go back to 1999 when I'm writing it. It's a time machine. Okay? How will I know what you want to do 21 years from now? What do you want to do? Do you want the program to crash? Do you want the program to say, I can't do that, give me another value? Do you want the program to just carry on and ignore the bug? I have no idea what you want to do 21 years from now. But what I can do is raise that exception to let you know that something funny happened, and then you will deal with it however you want. It's not up to me what you do, it's up to you what you do. Because I have no way of knowing what you want to do to solve this exceptional situation. Yeah, okay, whatever. So, if you're ever writing software that you're using a function that might throw an exception that you want to deal with, it'll look something like this. Function, it doesn't have to be a function, but if you've got code and you say try, function that can raise an exception, like my divide function that I wrote, that might raise that exception. Other programming languages say throw exceptions, same thing. So you say try to do this. And if it goes successfully, great. It skips everything in that except. And it goes on to code that runs regardless. But if that function, like that divide, someone tried to divide by 0, raises that exception, that code in the except will run. You would say except, I don't know, value error, whatever the type of exception we're catching is. In fact, you can actually have multiple excepts to catch different types of exceptions. But anyways, you can kind of think of this like an if statement. Run. If something went wrong, do this. Otherwise, skip. It's just like an if statement, but for this weird exceptional situation. It's not typical. Exceptions should not happen frequently. Ideally, they shouldn't happen frequently. But if they do, we have a way to manage this. So Jane wants us to set the result to not a number if we try to divide by 0. Many programming languages will have like an integer. Like let's say you have an integer. You've got something that's a type integer, but we need a special type of integer to let us know that, okay, it's an integer, but it's actually not like a number. Right? So in this example, if I tried to divide by 0, Jane wants us to set the result to this special thing, not a number. This is a reasonable thing someone might do. So what does their code say? Res for result, divide A by B, except 0 division error, and if that's the case, take the float, not a number. So res is not a number. It gets that special value. If the result, it doesn't throw that divide by 0 problem, it just skips. Res is whatever the result is. But Jane's decision, when using the code I wrote in 1999, was to just like, okay, just know that that's not possible and carry on. Set it to the value, not a number. But Bob, here's what Bob wants to do. Bob is saying, okay, read in some input, get the A and B. Try to do the division. So this is the example I was talking about, reading data in and trying to do the division. And what Bob wants to do is, okay, try to divide, except zero division, bad input for division, divide by zero, try again. So they just present like a warning to the user, and then you'll see that code's actually in this like while loop, while true. So that loop will run forever unless we get to that break statement. Raise your hand if you've seen break before. 2 people. Break is a fancy keyword that says, it's like, stop, jump out of the loop. By the way. So this is a way to say, keep asking for input and tell the user there's a problem until we actually get the result we like, then we can break out of the loop. Great. So Bob's solution to the divide by zero exception was just keep asking. So you'll see, Jane and Bob had 2 different ideas. Both are fine for what they need. So let's say someone's programming a piece of medical equipment that gives radiation therapy to people. And if the calculation goes wrong, we need that equipment to just stop. You know what, if something goes wrong, let's stop bombarding the person with radiation. Does this seem like a good idea? That seems like a pretty damn good idea if you ask me. So maybe we'll say, well, I missed it. Tim, we call exit. Except, and if we see exit, that exit function tells Python just stop executing. We haven't used it, we don't really use it very often, but every once in a while, like in this situation, this means stop. So in this exceptional situation, they decided immediately stop, just stop what you're doing. And let's say we have another person that's writing code for a helicopter. Do you think, imagine you've got the program running that keeps the helicopter flying. Do you think the previous example is a good idea if we run into a calculation problem? Absolutely not. You're in a helicopter mid-flight, something goes wrong, immediately stop. Not a good idea. They just say, okay, whatever, just carry on, move on, it doesn't matter, just keep in the air. So I've shown a couple examples of, look, some calculation might throw an exception. The person who wrote the code that raises the exception has no idea what you want to do tomorrow, the next day, in the future. They have no idea what you want to do about it. So I can't write the code for how to deal with this exception. You have to. And this gives you a way, a mechanism to do so. Exceptions actually have a type. Exceptions are technically errors. Why do we care? They're great. I'm not going to test exceptions. They're not going to be on the exam. Again, this is just me showing you these are things. If you go on, maybe you don't even carry on in computer science, but you use coding a little bit in the future, it's good for you to be aware of these things and take advantage of them. So this is more just for your edification. Any questions about exceptions? All right, now, the next thing we're going to talk about, this page and the next page that comes after this one, they're connected, is the last content that I will test on the exam. Everything after, very interesting stuff. Very important critical computer science stuff. I'll show you data visualization, and if we have time, I'll even show you some simple machine learning. Pretty crazy stuff. but those things won't be on the exam. I'm showing them to you to show you that computer science goes in a lot of different weird directions. That can be a lot of fun. That you might not think about when you take your intro CS, we're learning to program class. So, objects, classes, are the last big thing we're going to learn. And I guess we're going to start this on Tuesday because we don't have time today. So, by the way, they're not hard, but people can have a bit of an issue with just kind of like switching that paradigm a little bit. Anyways, we'll pick up here on Tuesday.